Okay, in this lesson of chapter 8, we're going to start talking about some trigonometry. So that word is a lot scarier when you're not familiar with it, but hopefully this will kind of give you a good introduction into trig a little bit. So it says trigonometric ratios, the ratio of the lengths of two sides of a right triangle. So we've been talking about ratios, right? And comparing similar triangles and different relationships. So when we actually specifically are talking about a right triangle, a 90-degree angle in a triangle, that triangle, and we are talking about two of the sides, and we write them as a ratio. So like this side over this side, or this side over this side, or this side over this side, or vice versa, whatever. That's called a trigonometric ratio. And the three most common types of trig ratios are sine, cosine, and tangent. And we abbreviate those as SIN, COS, and TAN, but we call them sine, cosine, and tangent. Okay, so we're just going to kind of real quick get into what these are, and I'm going to give you my little shortcut version of it, right? So I have to, first of all, be talking about a specific angle. I can't just say sine. The sine of what, right? It's an operation. There is a button on your calculator for sine, cosine, and tangent, right? And we are going to be using those. But what are those, right? The sine of angle R, here's angle R, is the opposite over the hypotenuse. Now this makes it look tricky, right? This abbreviation right here, we call this SOHCAHTOA. And that sounds funny, right? Like, what language are you speaking? SOHCAHTOA. This is sine of an angle equals the opposite side over the hypotenuse. Cosine of an angle equals the adjacent side over the hypotenuse. And tangent of an angle equals the opposite side over the adjacent. Okay, so we can actually, knowing the length of sides, we can calculate the size or the measure of an angle, right? So if I'm talking specifically about this triangle, okay, and I'm looking at angle R, this angle right here, and I want to try and figure this out. Now I have to actually have numbers here. This is just kind of theory right now. We have S, R, and T. I have to actually have numbers to be able to figure out the angle. But to figure this out, I could use the sine of R, which is the opposite side over the hypotenuse, right? Sine is opposite over hypotenuse. I could try and calculate it using cosine. Cosine of this angle is the adjacent side over the hypotenuse. Adjacent over hypotenuse. So if I'm looking at this angle, the adjacent side is the side touching it, right? In any right triangle, you have a hypotenuse, which is just the longest side of the triangle. That doesn't change. The side opposite of an angle is the side straight across from that angle. So for angle R, the opposite side is this guy, right? Which has a length of lowercase r. And the adjacent side is the third side. It's the side touching the angle. And for angle R, the adjacent side would be this guy, S. Okay, so if I was going to write a ratio, the sine of angle R, sine is opposite over hypotenuse. Oops, let me scoot this up a little. Opposite over hypotenuse. So I would write R over T. Here's angle R. I'm looking for this measure. So I would take the sine of R over T. So when I write that, I'm not taking sine yet, that's going to be in the next video, but when I write that ratio, I would write sine of R equals this over this, R over T, right? The cosine of that angle equals adjacent over hypotenuse, or S over T, and the tangent equals opposite over adjacent, okay? Why do we need to know all that? Every single operation here gives me the same answer, right? It's kind of like when you did systems of equations back in algebra and you had graphing, substitution, elimination, but they all gave you the same answer. It was just different ways of finding the same answer. If I'm looking for angle R is one angle. It's got one measure, right? Might be 52 degrees, it might be 48 degrees, whatever it is, there's just a few different ways of finding it. Why do I need 3 different ways of finding it? Well, it depends on what measurements you have in your triangle, because a lot of times you won't be given all 3 sides. Maybe they won't give you the hypotenuse and they just give you this side and this side. So you'd have the opposite side and the adjacent side, right? Well, if you don't have the hypotenuse, you can't use cosine because you have to have hypotenuse for cosine, and you can't use sine because you have to have hypotenuse for that. So if all I'm given is, for angle R, the opposite side and the adjacent side, I'd have to use tangent, right? So we just have some different options. So we've got opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. And the little shortcut to that, let me give you that one more time. Please write this down. This little SOHCAHTOA thing is like the quickest reference for all of this. So is sine, S, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, A over H, adjacent over hypotenuse. And TOA, tangent equals opposite over adjacent. This is your like little shortcut. All right, so let's do some math with that. And you know I'm a visual learner. I tell you guys that all the time, so I had to go ahead and highlight whatever. So in the directions here for this study guide, it says find sine of j, cosine of j, tangent of j, and then the same thing for angle L, right? So for all of these problems, for all three angles triangles we're gonna look at, we've got angles J, L, and K. Now K is our 90-degree angle. We don't need to find angle K because it's 90 degrees. We already know what it is, but we don't know the other two. What we do know is the length of all three sides of this triangle. So we can use any of the trigonometric ratios, right? We can use sine, cosine, or tangent. Because we're not missing anything, we can use any of the three. All right, so for sine of j, where's angle j? First of all, we find angle j. And what's sine is opposite over hypotenuse, right? Go back to your little reference sheet that I gave you. Sine, opposite over hypotenuse. So for j, what's the opposite side of j? Here's j. So the side opposite of that is this guy. So that's 12 over the hypotenuse. And for any triangle, any right triangle, there's only one hypotenuse. That doesn't change. 20. Okay, so the sine of j is equal to 12 over 20. And then, of course, we can change 12 over 20. We want to change it to a decimal. Now, the reason we're changing it to a decimal, because I always tell you guys, leave it in fraction form unless it gives you decimal. For trig, you're going to change it to a decimal. Because in the next video, I'll show you how to actually find the measure of angle j. Right now, we're not finding the measure yet. We're just setting it up to find it, right? So we know not angle j. Angle j is not equal to 12 over 20. The sine of angle j is equal to 12 over 20. So we're going to talk about how to find the sine of it in just a second. But now I want to change 12 over 20 to a decimal. So 12 divided by 20 is 0.6. So the sine of angle j is 0.6. Angle j is not 0.6. The sine of j is 0.6. And like I said, in the next video, we're going to do something with these two pieces of information to actually solve for j. We're just setting it up in this video. Okay? Cosine of j, we're still looking at angle j. The cosine is the adjacent side over the adjacent side over the hypotenuse. So for cosine, I'm not looking at the opposite side. I'm looking at the adjacent side, the side touching angle j. So adjacent is 16, and its cosine is adjacent over hypotenuse. Hypotenuse is still 20, right? So 16 over 20 is 0.8. Okay, now if I found the sine of angle j or the cosine of angle j, once I actually plug it into my calculator and solve, it's gonna give me the same answer. Sine is different than cosine, so it makes sense that 0.6 is different than 0.8. But when I simplify that, when I actually evaluate that, I'm gonna get the same answer. Sine of j being this, cosine of j being this. When I put it all in my calculator, I'm gonna come up with the same measure for angle j. And that's upcoming, so don't worry about that yet. Just understand why we're setting it up and that it's okay that they're different. Okay, tangent of angle j. Tangent is opposite over adjacent. TOA. T-O-A. Tangent equals opposite over adjacent. So for the tangent of angle J, the opposite side is 12, and the adjacent side is 16. Tangent's the only one where you don't have to know what the length of the hypotenuse is. For the other two, you have to know the hypotenuse, and then you can be missing one of the legs. For tangent, you do not have to know the hypotenuse. You have to know the other two legs. Okay? And then 12 over 16, if I simplify that, I get 0.75. Okay, so far, this is like, we're stopping halfway. We're not solving yet. We're stopping halfway. This is our halfway stopping point. Set up the ratio, and then change it to a decimal. Okay, that's what we've done. So that was all for angle J, this guy. Now we're gonna look at angle L, and we're gonna do the same thing. We're gonna set up ratios. So if angle J, if the sine of angle J is opposite over hypotenuse, my opposite side is this guy, right? This line right here, which is 12. Well, for angle L, that's no longer my opposite side. What's the side opposite of angle L? The side straight across from it. This guy. So it changes slightly, right? So if we're looking at a different angle, my ratios are going to be different. The only thing that stays the same, because this is a right triangle, is the hypotenuse. It doesn't matter which angle I'm referring to, 20 is always the hypotenuse. Okay, so for angle L, sine is opposite over hypotenuse. That's going to be 16 over 20. 16 over 20. Cosine is adjacent over hypotenuse, so that's going to be 12 over 20. And then tangent is opposite over adjacent, 16 over 12. The side opposite angle L over the side next to angle L. Opposite over adjacent, 16 over 12. Okay, and then we can change all of those to decimals. So this is going to be 0.8. This one's going to be 0.6. And this one, tangent's going to be 16 over 12. It's going to be 1 point something. 1.3 repeating. Put the little repeating sign over it. Okay, fantastic. And then when you start looking at this, it looks funny. Like the sine of angle J is 0.6. The cosine of angle L is 0.6. But remember, cosine is a different operation than sine. So just because they both have a 0.6, and they're talking about two different angles, they're not going to come up with the same answer once we plug it in our calculator and spit it out, okay? But again, you can't start plugging stuff in until you know what to plug in. So we got to set it up. All right, next angle. I'm going to go a little bit faster. If we start off looking at angle J, next triangle, angle J, okay, sine of angle J is opposite over hypotenuse. That's 24 over 40. Cosine of angle J is adjacent over hypotenuse, 32 over 40. Tangent of angle J is opposite over adjacent, right? So that's 24 over 32. And before I move on to angle L, I'm going to change all those to decimals real quick. So 24 divided by 40, 0.6. 32 divided by 40 should be 0.8. Yep, 0.8. And 24 divided by 32 is 0.75. And it's just coincidence that they happen to be the same thing here, because this is a completely different measurements of this triangle than this guy. Actually, it's not. It's actually proportional, because this was 20, and they doubled it and got 40. This was 16, they doubled it and got 32. This is 12, they doubled it and got 24. So these are proportional triangles. We actually should end up with the same answers here for both of these. When you have proportional triangles, the side lengths are not the same, but they are proportional. Corresponding sides are proportional, but all the angles have to be congruent in both the proportional or the similar triangles. Okay, so then we have angle L. So it should be the same. It should be the same numbers that we got here, but let's just make sure. So the sine of L, sine is opposite over hypotenuse. Here's L. So opposite would be 32 over hypotenuse, which would be 40. And if we divide 32 by 40, we get 0.8. Okay, cosine of L, here's L. Cosine is adjacent over hypotenuse. Adjacent, the one touching angle L, over the hypotenuse. 24 over 40. And when we simplify that, we get 0.6. Divide it in your calculator. 24 divided by 40 is 0.6. And then lastly, the tangent of angle L. Tangent is opposite over adjacent. So 32 over 24. And 32 is bigger than 24, so we know it's going to be an improper fraction or a number bigger than 1. If you divide it, you get 1.3 repeating. Okay, so far so good. And then last triangle over here, we're going to start with angle J. So we have sine of angle J is opposite over hypotenuse, so that's 36 over 24 square root of 3. Right? And then I can simplify that before I divide it in my calculator. I can simplify that. 36 and 24 can both be divided by 12. So that's going to be 3 over 2. And I get square root of 3 down there. And then if I multiply the top and bottom by the square root of 3, on the bottom, these two get squared. So it actually, square root of 3 squared is just 3. So I end up with 2 times 3, which is 6, and this is going to be 3 times the square root of 3. And I can simplify 3 over 6 to 1 over 2. So this is going to be square root of 3 over 2, right? And then I want to change it to a decimal. So I'm going to start with square root of 3, square root, divided by 2 equals 0.866. I want to round to the nearest, what does it say? Round to the nearest hundredth, it says. So I'm going to make this 0.87. So the sine of J is equal to 0.87. Okay, so and you didn't have to go through all that simplifying. You could have put this in your calculator. But to me, I can't just type in my calculator 36 divided by 24 times square root of 3, because it's not going to do it right. I got to simplify the bottom first. Okay, cosine of J. Cosine of J, here's J, is adjacent over hypotenuse. So 12 square root of 3 over 24 square root of 3. 12 square root of 3 over 24 square root of 3. Okay, and here our square root of 3's cancel each other out. So I'm left with 12 over 24, which is 1 over 2. Which, when I simplify, is 0.5 when I change it to a decimal. Easy peasy. Okay, and then lastly, tangent of J. Tangent is opposite over adjacent, so 36 over 12 and a third. 36 over 12 and a third. And 36 divided by 12 is 3, so I get 3 over a third. Can multiply the top and the bottom both by square root of 3. Square root of 3 times square root of 3 just becomes 3. And on the top, I get that. And then the 3's cancel, so I'm left with square root of 3, which is 1.73. I have to round to the nearest hundredth, so I get 1.73. 1.73. Yes, you are gonna get, that's the hardest part about trig, you're gonna get funny numbers. You're not gonna feel good about it. You're not gonna get an answer that's a nice rounded off. Sometimes you will, but you will get these weird, funky answers, and it's okay. Because once we do our last little step, which you're gonna do in the next video, then you'll see it kind of come together more, but you are going to have to round a lot, so come to terms with that. Let yourself be okay with having these weird numbers. Okay, sine of L, so now we're changing angles. Now I'm looking at this guy, so sine is opposite over hypotenuse. Opposite over hypotenuse, 12 square root of 3 over 24 square root of 3. I like that one because the square root of 3's cancel each other out. This cancels this. 12 divided by 24 is 1/2 or 0.5. Okay, and then cosine of L, that's adjacent over hypotenuse. 36 over 24 square root of 3. 36, 24 square root of 3. Now, I already simplified this ratio up here when I did sine of j. Now I'm doing cosine of L, but I still get the same ratio. So when I simplify it, I'm going to work smarter, not harder. I've already done the work, so I know this is the answer, right? So I'm just going to put 0.87 without having to show all that, because I've already done it. And lastly, tangent of L is opposite over adjacent, 12 square root of 3 over 36. I can divide the top and the bottom by 12, and I get square root of 3 over 3. And I think I've already done that one as well. Nope, I did 3 over square root of 3. All right, so I got to redo this one. Square root of 3 divided by 3. Is that what I got? Yeah. 0.58 if we round to the nearest hundredth. 0.58. 0.58. Okay, so step 1 looks pretty messy, right? Step 1 looks pretty messy. And then we're giving you a lot of stuff to do too. Like normally you would just have one angle, right? This is just practice on knowing how to set it up. So the biggest takeaway from this lesson, if you need to go back and review it, please do it, because we're only going to move faster now going forward, is this SOHCAHTOA. Try to understand SOHCAHTOA, right? So if I have a right triangle, this guy, and I am talking about this angle right here, okay? Talking about this angle. And I want to find the sine of this angle. Sine is opposite over hypotenuse. So I would do this side. This is opposite over this side, right? So if this was, let's say, what do we do, 3, 4, 5, I think. If this was 4 and this was 5, then I would do sine of whatever this angle is equals opposite over hypotenuse, 4 over 5. And then I change 4 over 5 to a decimal, and then I do one more step with it, which you're going to learn in the next video. Okay, so opposite over hypotenuse, cosine is adjacent over hypotenuse. So we got opposite over hypotenuse, that's one ratio, that's the sine. Adjacent over hypotenuse, that's another ratio, that's cosine. And tangent, we just forget hypotenuse altogether, and we just do opposite over adjacent. Right? So you're just coming up with ratios, changing the ratios to decimals. That's it. Let me know if you have questions.